Today we're going to talk a little bit about where integrating factors come from and how to use them. So an integrating factor is used to solve first order linear ODEs. And before you do anything, or before you start using an integrating factor, you should check, or you should put your ODE in standard form, which looks like the derivative here on the left plus some function of x times y, and then equals a function of x by itself. Quick note, before you go off and start finding integrating factors, you should always check if the ODE is separable first. So separable ODEs are much simpler to solve, and so you should just check that before you get started. Just a heads up. And the idea behind integrating factors is to multiply the ODE by some special function u of x, which we'll figure out what that should be in a moment. Multiply the whole ODE on the left and the right side. And the idea is to make the left-hand side look something like a product rule, something like the derivative of, so the derivative of something equals some function of x. And if we just have one derivative on the left, we can integrate both sides right away and figure out what our function should be. So that's the idea for integrating factors. So let's go ahead and figure out where that comes from and how we would do this. Okay, so I would have y prime plus p of x y equals q of x. Okay, and the idea is that I would multiply both sides by this function u of x. So I'm going to go ahead and multiply u of x on both sides. Again, I don't know what u of x should be at this point. I'm just kind of trying to figure out what I want it to be. Okay. And the idea is that we want this left-hand side to look like a product rule. So we want this to look like d dx u times y. So again, this is two functions of x, and so you would have to do some sort of product rule to take this derivative. So we want to go backwards. We want to start from like a fully fleshed out product rule and put it back into the form d dx of the derivative of two functions multiplied together. And then we just kind of leave the right hand side alone, u of x times q of x. Okay, so that's what we want. Let me grab this, copy that. I'm going to go down to the next page so we can keep working here. All right, so this is where we left off. And we want to figure out how to find u of x. So how do we figure out what u of x should be? What u of x should be? Okay. We're going to do this by just taking this left-hand side here, this d dx u times y. We're going to do the product rule here and then try to match it to what we hope is the result of that product rule. Okay, by doing that, we'll figure out what u of x needs to be. So I'm just going to do the product rule here. Okay, so I'm going to get u prime y plus u y prime. Okay, and I'm going to, I want this to be equal to something, so I'm going to put an equal sign. I'm going to put a little note here that this is what we want. We want this to be equal to u y prime plus u times p times y. Where am I getting that? I'm getting that from up here. Okay, I want this to be the result of doing the product rule on the product u times y. Okay, so now I'm just going to go ahead and match up the terms here. So let's see the terms that that work out. We have a u y prime already, so u y prime's already there. We're good there. We have a y here, so that's good. The only thing that's sort of missing here is this u prime is in front of y, and over here it's u times p. So we need these to be equal. Okay, and that's going to tell us what u should be, what u of x should be, our integrating factor. Okay, what does it mean if those two terms are equal? This is, so I'm setting these equal to each other. This is u prime. Maybe I should use a lighter color because that's a little dark. U prime, I need u prime to be equal to u times p. That'll make these two expressions match. So that means that du dx, or u prime, I want that to be equal to u times p. And now I have another little differential equation inside of my, my problem here. But notice that this is a separable equation. Separable. We can solve this, no problem. So I'm going to go ahead and separate the variables. We'll get du over u, the integral of du over u will be equal to the integral of p dx. So I separated the variables here, got the u with the du, and the dx with the function p of x, and then we integrate. And if you do that integration, you'll get that u of x is equal to e to the power, the integral of p dx. So the power on e here is the integral of p dx. This is our integrating factor. So this is our integrating factor. And notice I don't have, you know, when you integrate, you usually have a capital C here for a constant. Sorry, that wasn't very clear. You usually have a capital C here as your arbitrary constant. For the integrating factor, you just need one function that works. The arbitrary constant will come in later. So you don't include the arbitrary constant here, that capital C. That'll come in later when we solve the original differential equation. So this equation without the u's involved. So once we solve that differential equation, then we'll get our arbitrary constant. All right, so I'm going to go ahead and scroll down. We found our integrating factor, and now we kind of need to see how it works, figure out how to use it. Okay, so the original equation we were solving in standard form, actually, let me get a smaller pen here. Here we go. Y prime plus py equals q. So we need to multiply both sides of the ODE by the integrating factor. U of x equals e to the integral of p dx. Okay, let's see what happens when we do that. So doing this gives us, on the left we would have d dx of our integrating factor, e to the p dx, times y equals e to the integral of p dx times q. Okay, so I went straight to writing this as the derivative of a product. You can multiply both terms here by u of x and then rewrite it as the integral of a product just to check that you did this correctly. But this is exactly how we chose this function, is that if I multiply both sides of this equation by u, I should be able to then write the left-hand side in this way. Okay, once we're able to rewrite the left-hand side, then we can integrate. Then integrate both sides of the equation. Okay, so integrating the left-hand side, we just have a derivative in x. So if you integrate this left-hand side, this derivative just goes away. Okay, so we're finding the antiderivative here. So you got e to the p dx, or sorry, the integral of p dx, y. And then we would have the integral of e to the integral of p dx, q dx. Okay. And then from there, you would just solve for y. And by solving for y, I mean you're just going to multiply by both sides by e to the minus the integral of p dx to kind of get that to the other side. e to the minus integral p dx, and then times the integral e to the integral p dx q dx. And that would be your general solution to the ODE. The arbitrary constant would come in once you actually do this integral. Okay. So I know this looks like a lot. You shouldn't memorize this formula. All you maybe want to memorize is that this is the form of the integrating factor. So the integrating factor is e to the integral of this function here after you put the ODE in standard form. I'll do another video later where we actually see an example of this in action. Let me scroll down a bit. Okay, and I'm going to go ahead and paste a few points I want to make before we wrap up the video. Actually, I'm going to move this up a little bit. There we go. Okay, how would you solve first order linear ODEs? First, identify it as such, so make sure you know that you're looking at a first order linear ordinary differential equation. The first step I would recommend is check if it's separable, okay? Because separable differential equations you can kind of solve after only a few steps. You don't have to go through all of this work. If it's not separable, then put the ODE in standard form, y prime plus py equals q, where p and q are functions of x. I just left that little part out to save space. Then you would find your integrating factor, so that's e to the integral of p dx. Multiply both sides by that integrating factor, rewrite the left-hand side so that it looks like this, integrate both sides, and then last but not least, solve for y. I'll do an example in a video later on, but that is where integrating factors come from, and that's how we know what form they should take.